seeing at Emesent, valuing putting a product together that is making the process easier and also making users confident in the data that they're coming out. Take a real leap forward in the market with a product that's really encompassing on every level, getting everything that Emesent has learned over the last 2 products to create a product that's truly encompassing all that innovation in a really simplified but powerful user experience.
Great. My name's Andrew Harrison, and I'm the hardware team lead here at Emesent. My role in bringing this product to life has been to guide the hardware team, which consists of mechanical and electrical systems design, as well as embedded firmware design, to take the product from concept through to production and build that next generation product for surveys that we want to make.
Hi, my name's Sam Prudden. I'm a member of the hardware team. My position is a senior aerospace engineer, and my main responsibilities for the GX1 product are mechanical design and development.
Our initial goal when building the product was to bring our incredible LiDAR-based mapping technology from our clients who operate in some of the most challenging conditions with our robotic platforms into the survey market. We just found that one of the key things that kept coming up over the last couple of years was that we had a lot of clients who were wanting to take kind of our speed and slim robustness in a lot of challenging environments and apply it to more traditional kind of survey applications. And that led us towards doubling down on that key technology and building something that surveyors could use day in, day out to accelerate their workflows and produce better data. The physical design went through 3 major design iterations. The first of which was all about feasibility. We needed to know out of the gate, can we build the product that we want to make? So while it resembled largely the NGX1 product, it also looked like something that was a little bit sci-fi. An aluminium frame with a lot of sensors bolted onto the side of it.
When we were developing the early development platforms for the GX1, we captured our initial scans, and when we got the data back, we got very much under sub 10 millimeters of precision. And considering that this was like a thrown together prototype with the representative drive system, its ability to generate this kinds of precision levels that early in the project really sort of sealed the deal for us, knowing that we're onto a winner.
A lot of the initial sketches for the GX1 shared some similar design aesthetics. They all followed a very similar kind of vertical design aesthetic, which came from a form follows function approach. We knew that with the RTK receiver, with the camera systems, and also the LiDAR, that we wanted to maximize their field of view. We wanted to ensure that all of those sensors could be used to their maximum potential. The second iteration that we moved on to was a lot closer to what we've ended up with today. We knew that there were a few high-risk aspects of the design and a few things that we wanted to validate with customers early, so the second iteration was all built around doing those quickly. That was really useful to help us get some feedback in the middle of the design cycle, such that we could still make some improvements before going into a more locked-down design.
One of our major focuses from a mechanical perspective was to provide a really rigid and robust basis from which the SLAM sensors could be used to generate a really accurate and repeatable map. The algorithm which we use for our SLAM really sort of works around the use of a rotating LiDAR assembly. And so this then drove the configuration of the rest of the product upon which we arranged the rest of the subsystems around.
The most fundamental challenge that we had in developing the GX1 was taking all of our high performance sensors, but putting them into a really small package. While none of the sensors individually are too large, they all have a lot of requirements to work around, and packaging them really closely together presented a number of challenges that we had to overcome in the design. The entire chassis is extruded from a single piece of aluminium, which allows us to really maximize its properties by not having any joins or breaks in the design, so we get something that looks incredible, but also from a performance standpoint is superior to any other concept that we looked at.
We ended up using is what we call this coupled sensor head configuration. What this does is it rigidly couples all of those critical sensors into the top unit and ensures that even when they're subjected to all these really crazy environmental conditions, they stay together and they provide consistent data.
While on the bottom of the payload, that's where we house the battery and our compute system. We've thermally isolated the 2 systems. So any heat that's produced by the battery or the onboard computer won't influence our sensors, meaning that we can achieve really high performance even in some very challenging hot environments.
All of these systems have a variety of field of views. So with the LiDAR, it needs to be able to see the horizontal axis with a little bit of up and down. The cameras are the same, but the RTK always needs to see the sky. And at the bottom, we need a way to mount it. And so this is what led to this stacked configuration that we have here with the top mounted sensor head. As engineers, we want to add the maximum amount of functionality, modularity, and mounting points specifically to the product. We want tapped holes, we want mounting rails, we want it to just be capable of doing anything and everything.
So to help us get to where we want it to be with the design aesthetics, we worked with a design studio in Byron called Catapult. They're just down the road from us in Brisbane, and we actually had one of their engineers throughout the whole project embedded in our office. That allowed us to work really closely with them and give them a really good understanding of the problems that we were facing and why some things were really central for us and where we had more flexibility.
So with the technology pack that Emesent has already, there's a real track record of being able to make sure everything's optimized for function and performance. And part of the GX1 process has been, how do we maintain that flexibility so we can adapt it to new user markets and new applications that we haven't even considered yet with Emesent's, power users, as we're calling them. And how do we also make sure that all of that technology stack is slimmed right down into one product that's easy to use, but that's accurate. And I think we've done a really good job using a lot of the internal knowledge and learnings from the previous products and some of the experts within the team to make sure that we're still optimizing for accuracy, but also optimizing and creating a holistic user experience.
We worked closely with our industrial designers and they really helped rein us back because we wanted to make this product sleek and aesthetically pleasing to the user. And so one of the ways that they did that is by sort of guiding us through design processes where we use the limited amount of externally facing fasteners because it allows us to have this kind of consistent external profile. Also, the way that the curved surfaces blend together. We use things called curvature continuous surfaces, continuity of form. So you can see at the top, we've got this squircle profile that we use. This is a sort of a motif that we use throughout the product. And so this was sort of a design process we went through and a lot of learning experience for us as engineers to help generate this really aesthetically pleasing product. I think in terms of Emesent's sort of position within the industry, this is definitely one of the most impactful products because HoverMap has been such a versatile platform across many different industries, but this is sort of us staking our claim within the AEC space, and we really want to go off with a bang with a really nice, accurate, precise, sleek, elegant product that makes waves.
Someone who's never picked up a Emesent product in the past can just start and get really great mapping, and that's considering from loading the device out of the backpack all the way through to putting it onto the pole and mapping data. It's at every level. It's about getting everything that Emesent has learned over the last 2 products that you guys have put out to create a product that's truly encompassing all that innovation in a really simplified but powerful user experience.